wall of the second floor. Let's go to 3D so that we can see. Here is where we stop. Like at the second floor, we didn't do the interior. So we did this the other time, and then we will continue from here. Okay. So what we will do today is we will do the foundation, and after the foundation, we will do the interior wall, after the interior, and then we will do the roofing. Okay, so let's just hop in straight and forward. So to design the foundation of this building, we need to understand a couple of things. What is the foundation depth, the foundation thickness? But now we are not doing the structural designing aspect. So it's not we are going to use the possible thickness of the foundation. It doesn't matter at the moment the type of foundation we are going to use. In most cases, it comes with the soil report or the structural designer. The structural designer that is going to do the structural analysis determines the type of foundation that you are going to use. In engineering, we have different types of foundation, in which we have what? The pipe foundation, and we have pad foundation, and then we have slab foundation, and then we have a lot of more foundation, which I believe you know them, because even though it's for beginners, I expect that you have a little bit background of civil engineering in your head. So now, the type of foundation to use, like I said, is going to be determined by the geotechnical engineers or the structural designer, even the thickness of the foundation. But for us today, it doesn't matter anyone we're going to use, because we are designing the architectural aspect, and I don't want to go deeper in the structural analysis of it right now. So let's go back to elevations east. You can see that. Let me do this, something like this. Fine. Not realistic. Oh my God. Let's shade. Okay. So here, if you can see that from our ground level, we need to what? Put the thickness, the depth of our foundation from our ground level. At this very moment, I will create a level which I will name it what? Foundation. But the depth of the foundation doesn't matter, which I will use 1000 millimeter. 1000 meter. But it doesn't matter at the moment, because we are not doing the structural analysis, and we don't have the soil report. But now I'm going to show you or explain to you how to go about let me confirm whether this is recording. Yes, I'm not going to explain to you how to go about uh, um, analyzing the soil report from the what? From the geotechnical engineers. So I have an article that has been published here in the Cambridge Journal, maybe something like this, is a geotechnical report from geotechnical engineers. If it is important for you, you can read it, it doesn't matter. But if you have a report, like a soil report from geotechnical engineers, the first thing you need to go and look at is what is the safe bearing capacity of the soil in which the foundation is going to be drawn on. What is the soil is going to be laid on. So what is the soil bearing capacity? So we find out that the safe bearing capacity of this lab, from the summary of laboratory test result from the geotechnical engineer, the safe bearing capacity is from 107 to 156 mil. Yes. So from 156, okay? So this is the word safe bearing capacity of the soil, which they used this instrument to find the safe bearing capacity. But after you find the safe bearing capacity, it is important for you as an engineer to know what is the what? There's something we call safe factor, safety factor. The safety factor, it comes, I think most at times people use 2.5, but it can be, it's 2.5. I think so. 2.5. So you have this. You go to the summary lab laboratory test and result, get this. So it means that what from here, it means that what we are using anything from 107 to 156. So you have to put it what in your mind. Okay, this is what you're going to use. So based on my experience, I will tell you the truth. Like in most cases, we use safe bearing capacity, soil bearing capacity of from 150 above. Okay, above. So in most cases, so let's go on and see what from the results they got. Okay. Um. Yes. Okay, let's go to conclusion. Okay, result of the geotechnical investigation shows a safety bearing capacity of this, like we said it, but it shows that this one is from TP1, and in TP5, when it is 1 millimeter, it means that what? 1 meter depth, they have to do what? TP1, TP2, TP3, TP4, TP5, TP6. So what they are saying here is at 1 millimeter, at 1000 millimeter depth, the safe bearing capacity is from 107 to 124 kilonewton per meter square. Okay, kilonewton per meter square. Which, for me, like I said, from the experience, it is important to take 150 above. So now, from that 1 millimeter, 1000 millimeter depth, they now move to, okay, we have not gotten our allowable bearing capacity, which, like I said, is mostly 150. So they have moved from 1 millimeter, they have now gone 2 meter depth in the ground, which from the 2 meter depth, you see that the bearing capacity has increased from 145 at TP2 is 156. They did not even go to TP5. From TP1 to TP2 is now from 145 to 156. If it was me now, I will what carry, I will use 2 meter depth with 150 bearing capacity because what it is safe. Do you understand? So you now find out that the minimum here at 1 meter is 107, which we have seen it here 107, and the 150C, it comes from what? The 2 meter depth at TP2. They stop there. Do you understand? And they use a safety factor which I explained to be what? 2.5. Okay. So they also tell you that they also said it here that the soil in which the foundation is going to be laid on is going to be lateral soil. And then here you see that the recommended type of foundation you are going to use is 2 millimeter depth. As a structural engineer, after you have gotten this, you will go after you do the you go and carry out the analysis in the software. And now you have to indicate and put all the necessary things, the 2 meter depth and also um the safety bearing capacity of the soil, and then it will now bring out the result. So from the result, you have to analyze. If the result is not good, you have to what? Improvise, either increase the thickness of the foundation, which is the part foundation, or you increase the number of reinforcement, or you increase the diameter of the reinforcement. Mind you, as a structural engineer, you always have what? The mindset of the economy. You don't have to be going extravagant, like just thinking about how the building will stand without thinking about the pocket of that company or client. So you can see that let's read the recommendation. Our recommendation as contained in the report are based on careful correlation and interpretation of the field and laboratory analysis carried out carried out. Result of the geotechnical investigation showed a safe bearing capacity range from this, like we said. So which one are we going to pick? We will pick 150. Let's see which one they picked. Where's the conclusion? Okay. You can see from here, there's a 2 meter depth. I say that the analytical bearing capacity computation revealed that the bearing pressure of the subsoil at the site are generally satisfactory for design at 2 meter depth with 150 kilonewton per meter square average. So this is the what? The depth of the foundation and the safe bearing capacity of the soil. This is the best to use based on the report we got. But from this one that we are seeing, from our building, we don't have any soil report. And so at this moment, we will take what? 1000 millimeter depth, and we will assume during the structural analysis that our safe bearing capacity of the soil is going to be what? 150. Hope you get what I'm saying. So let me explain the type of foundation. Here, it doesn't matter for us because we don't have any report. So we will use slab foundation. But in a situation, I want to explain what a slab foundation is and also what pad foundation and pipe foundation is, which I believe, like I said, you have knowledge of civil engineering, but let me just brush it quickly. Pad foundation is when you have something like this and what? And you have, uh, uh, I'm sorry, you have a column here. So this is a foundation. What is pad foundation? Pad foundation is a foundation where if a short foundation like a slab is being placed under the load bearing element. For example, column, for instance, where the column gets the load of the building and is now being passed to the foundation, which the foundation has it, the column has its own slab. Do you understand? Do you understand? So that is part foundation. In a situation where we have slab foundation, is a situation where you have what? Um, Foundation is being laid, a slab is being laid under the whole building, for example. So if your building is like this, for example, you might have a building like this, and then foundation is being laid completely under the ground, and so any element is going to come out from the foundation. So in a situation where you are doing slab foundation, sometimes it's not economical because you have to what, spend a lot of money, but it is always good to use slab foundation when you have what, uh when you are designing a building, or when you want to construct a building that has many floors, for example, for example 10 floors, 12 floors. In that situation, what the load that will come from such building is huge, and in that situation it's good to invest in your foundation. Hope you understand. And there's something we call pile foundation. Pile foundation is a situation where it's like a needle, or it can be in a rectangular or anything, where you drill or you put concrete down straight to where the safe bearing capacities of in the soil is the to the required soil that you're going to lay your foundation. So it's like you have, let me design it for you. You have it like this. That's pipe foundation. And then maybe there's what we call a short slab here. In Russian, we call it rostver. Okay. So, or I don't know in English what it means. Anyway, it doesn't matter. So this is what pipe foundation. So you have, let's say, a couple of it. And then let's say, for example, one here, one here, one here, one here. And so what? Now you put a slab, you put a slab you put a slab on top, and then you continue your building on it. So this is what is called pipe foundation. Hope you understand. This is just a recap of what it is. So let's go back. So now to design our foundation, we will bring of course the load bearing walls to meet the level. So let's rename this level to be what we call it foundation. Mhm. I prefer to put the height, depth of the foundation. Let's put minus 1 meter. Let's put point 0. Mhm. Okay, point 0. So here, now let's click these load bearing walls. Everything here, I think they are load bearing walls. So let's click it, and let's select the level which they will start from our foundation. So if you go back to it, you will see it here. You see, we have it like this. But now we are going to design our foundation. To design our foundation, I have to explain one thing for you again that we usually do. Let's say you have a slab. Oh no, sorry. Let's say you have a slab like this, and the load bearing wall is coming like this. So why do we leave space here? Why do we leave space here? The reason why we leave space here is, for example, you have your wall like this. You might assume the load acting, coming. You might assume the load acting on this building, coming. We have it. So let's the load acting on this building is coming vertically, of course, vertically, right? Yes, the load acting on this building, they're coming vertically, and you might assume they will be put them down like in the foundation, like this, vertically too. But in the other way round, we have a different type of reaction that is happening here. The reason why I'm saying this is because, like, let's assume you are moving an object, like, or you are driving or riding a motorcycle. When you hit something, there's this type of force that drags you up, like you come out of the machine and then throw like in front. Do you understand? That's what we call repulsive force. Exactly. So in this situation, exact same scenario used to happen with the foundation and the element carrying the load from the building. And so this for load that they are coming, if they meet with this repulsive this thing, like they meet with the foundation, the load is not going to be vertical again, in the sense that the load will now be from vertical, it will start spreading like this. Like this? No, like this. Hope you understand. This is exact thing that is happening. The load is now coming vertical. It's no more coming vertical, but it's being spread. So to ensure that this load is spread uniformly to the foundation without any problem, it is always good to increase the uh, the foundation, the width of the foundation, to extend it a bit from the main structure of what you're designing. Okay, so it is very, very important. And the second reason that we do this one is, let's assume we have our of course, when you bring it out, we have our foundation cover like this. So this is where our reinforcement is going to be. You see, there will be a reinforcement here that is going to support, there's going to support the load that will be spread on. So like I said, we'll have load spreading like this, like this, like this. You can see that even if they are spreading, they will be uniform. The foundation will be able to receive this load without any problem. And so that is it, okay? And yeah, it's okay for now. It's okay for now. There's another reason that I want to explain. The other reason is that when you have a foundation cover, we try to what? Let me do it again. We try to put our foundation cover a bit, we're not using, let's say, 25. We can decide to use 40, for example, or 35. The reason is because to avoid, let's say, water or any reaction coming from the ground, because this is going to be beneath the ground, like below. So it means that what? There are factors that will be acting on this foundation. And so to avoid it, to avoid these factors affecting our reinforcement, let's say kind of from corrosion or anything, it's always good to what, extend the cover a bit. So when we extend the cover, it still keeps us what, in line with our structure. It does not change anything. But imagine if you don't have space and then you have something like this, and then the cover here comes like this. Well, it's good, but what happens if the load now is coming? If the load is now coming not vertical but other ones, then we'll have a lot of problems. So, anyways, you understand. It's just a recap of what we a recap for you. I believe you know it. So let's continue. Okay. So let's draw. Okay. Now I want to put the helping line that will help me to, let's put 100, or let's say 150. Yes, 150. So I want, before I design the foundation, I have to put like this, the outside, the extension that I showed you from the main structure, which I want it to be 150. So you put it like this, like this, like this. It'll be fast. Okay. And so let's align it. This one align with this one align with this. Okay. So now let's design our foundation. Let's go back to floor, structure, foundation, and then we will click on this one to help us. No, 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 no. We'll click on this one to help us pick the line. Pick this one, pick this one, pick, 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 pick. So we have it like this, okay? So we will click on which level that we want. We want this to be at the foundation. Then we click foundation. And then what is the, we need to choose the type of this one. Let's click edit type, the floor, and then duplicate this one and name it what, as foundation. Mm-hmm. Foundation. And let's say the thickness of the foundation should be 400, which let's use 500, please. For now, let's use 500. Okay. And then you go edit type. And here, of course, we don't need the finishing this one, so we delete this one. And the structure here, we'll name it to concrete. Yes, the first one, concrete. And then thickness here, we'll put it as 500, just like it's in the name. And then you click OK. And then everything is fine. Then you click finish. Then you go back to your building. You can see that we have our foundation. And this is what I was explaining to you here, over here. Hope you understand. Good. So now we are done with the foundation. Let me check again whether this one is recording. Perfect.